Okay, let's take a look at section 2.2, domain and range. Let's start with a definition. The domain of a function is the set of input values for which the function is defined. Said in a little different way, the domain is the set of legal values. It's the values that we can use for the input that actually makes sense for the problem. So recall from your past math that a fractional function is undefined when its denominator is equal to 0. And so the legal values for a fractional function are all of the values that do not make the denominator 0, assuming there are no other issues in the function. So let's take a look at a couple of examples. So a of x. A of x is equal to 8x divided by the quantity 2x minus 1. So remember, the domain, which is what we're looking for here, is where the denominator is not equal to 0. So what I'm going to do is I'm going to set the denominator equal to 0. So in this case, when I do that, that's 2x minus 1 equals 0. And if we solve that particular equation, add 1, divide by 2, we get that x equals 1/2. So x equals 1/2 is the value of x for which the denominator is equal to 0. And that is the only value for which a of x is undefined. So let's take a look at how we would write the domain, just very, very briefly. So if I were to look at a number line, and so in just a second here, I'm going to draw myself a number line. If I were to look at a number line, and on that number line, I put the number 1/2. Now what happens is we can use everything except that 1/2. So what's happening is I can't use the 1/2, but I can use everything above it, and I can use everything below it. And so I put a circle an open circle at the 1/2, make that easier to see, so that we could see that that's the one value that we aren't using. And so if I wanted to write that with inequality notation, that would be saying that it's the set of x, the domain is the set of x, such that x is less than 1/2, right? This is the x is less than 1/2 piece, union, or the set of x for which x is greater than 1/2. So it's x is less than 1/2, x is greater than 1/2. You know, commonly we might say it's the set of x such that x is not equal to 1/2. That's true as well. We've talked a little bit about interval notation. So I've written this in interval notation. And remember, when we write our interval notation, we look at this as, okay, what's the left side of the interval? What's the right side of the interval? So if I look at the first interval, the left side is going off to -infinity. And on this first interval, the right side is at 1/2. And remember, on infinity, whether it's positive or negative, we only use a parenthesis. The 1/2 we don't include, and so therefore it's a parenthesis on that as well. And then the same thing for the other side. The left side is 1/2, the right side is positive infinity, and again we use the parentheses. Let's take a look at example B. So I have b of x is x plus 1 over x squared plus 3x minus 10. So again we set the denominator equal to 0, so we get x squared minus 3x minus 10 equals 0. And when we do that, we notice that factors, and that factors into x plus 5 multiplied by x minus 2. So we set that equal to 0. And then remember, we set each of the factors equal to 0, and we get x equals -5 and x equals +2. So x equals -5 and x equals 2 are the values for which the denominator is 0, and for which the function's undefined. And again, if I look at that on a number line, what I actually have is -5 and 2, and they're the values we can't use, but we can use everything to the left of -5, everything in between, and everything greater than 2. And so you'll notice we get 3 intervals. We get x is less than -5, x is between -5 and 2, and x is greater than 2. And I wrote that in both inequality and interval notation. One more quick example. C of x equals x plus 3, the quantity x plus 3, divided by the quantity x squared plus 1. So notice, if we set the denominator equal to 0, we have x squared plus 1 is equal to 0. Well, think about it. Every time I square a number, I'm going to get a number that's at the smallest 0. And when I add 1, I'm going to get the smallest would be 1. X squared plus 1 will never be 0. And so the domain is all real numbers, which you'll sometimes see in the book written with kind of a bold-faced R for all reals. Or we could write in interval notation, and it would be everything from negative infinity on the left to positive infinity on the right. Okay, now you can go out and take a look at a number of the examples in the book dealing with finding the domain algebraically, and that's what we just have been working on.